welcome everyone to Awkward Devs number 132. Let me share the link in the agenda here. Couple things today. One, there was a Gordy issue and I think it's still ongoing, so it's worth addressing that. But right after that, a couple merge updates, some stuff on Kiln. There was some discussion about changing the random versus difficulty opcode in EIP 4399, and we have the folks from Kurtosis on the call as well who've been helping with testing for the merge, and they'll take a couple minutes to walk through what they've been doing and see if we can schedule a more in-depth testing discussion in the next couple weeks. And then some Shanghai stuff with some updates on the beacon chain withdrawals. And finally, there was a comment about one EIP where we would just cap the amount of transaction gas to a large integer value. So I guess to get started on Gordy, does anyone on the call have kind of an update about what's happening? Got it, thanks. Okay. Yeah, I think I don't know, Micah, if I understood your question correctly, but were you asking whether the Nethermind operated node was down, or whether if we knew that all the affected validators were running the same client? Yeah. Okay. Got it. Right. Cool. Okay, that's good to know. Cool. Um, yeah, so I guess we'll keep an eye on the Awkward Devs chat for updates about this. Yeah. Anyone else have anything to add on this? Okay.
Maybe Infura team could try it if you can get in touch with them. I think EG is on the Gitter channel, so maybe that could help them.
I mean, the problem is that I have absolutely no idea. So on Brinkaby, at least, we have all the signers on the stats page, so we know what they are doing. But on Gurley, the signers aren't really reporting, so nobody knows who is online, who is offline, which is on which chain. It's a bit of a black box.
Yeah, there's less visibility. I mean, there's stats Gurley net, but I don't have access directly to each signer's snapshot. Otherwise, I'll be able to check like who is on what branch.
Okay. There was a streaming problem and YouTube didn't get most of this audio, but in short, we discussed the Gordy's issue. We're still investigating the issue. We haven't found it, and we'll post updates in the Awkward Devs chat, and I'm sure people will share them on Twitter. Apologies for that. I'll try to make sure that we get the Zoom recording for the notes, so there's a full transcript, even though the video misses part of the audio. Anything else on Gordy? Okay. So next up, merge updates. I guess first of all, maybe it's worth Perry going over the DevNet that we launched and what the status is there.
Sure. Hey, so yesterday we launched a new Merge DevNet 4. It's based off the Kiln V1 specs, and we've had almost all the client teams taking part. I know that last night a couple more independently were able to sync up, so I think almost everyone has an implementation by now. I've pasted a link in chat with information on where to join, how to join. The only tooling that doesn't work right now is Beacon Chain, because our fork of Beacon Chain relies on Lighthouse, and yesterday we weren't able to get Lighthouse up and running, but that should be fixed soon. While the network was reaching TTD, we did have multiple forks. And different consensus layer nodes did observe different terminal block hashes. Even then, the network resolved itself as expected, and it's finalizing and working fine. Mikhail's just written a tweet with what the logic is for it to resolve itself. Again, to reiterate, there was no intervention done. This worked exactly as expected.
Did we induce the proof of work forking? Why did we have that?
Marius's computer was too fast.
That's great. Awesome.
Yeah, he just randomly started mining at some point, and I think he was mining blocks so quickly it wasn't importing anywhere else.
Excellent. Great test.
And I guess, does this give us like any kind of data or confidence about once we do this on mainnet, like how long we want to wait until we consider kind of the merge complete? Like, because you mentioned, I think on Twitter, it took overall like a number of minutes for this process to happen. Is that like roughly what we'd be expecting on mainnet as well? That after a couple minutes, the fork choice gets decided, and we manage to finalize a block.
in normal conditions, I would expect it even on the order of a slot or a few. It sounds like because the resolution on Marius's end, because he was mining blocks so fast, there might have been portions of the network that were still like importing blocks, and that might have been the delay there. Whereas that would be much more difficult to induce on mainnet,
Right.
although not theoretically
Exactly.
totally
So we had
impossible.
3 forks on the network. 2 of the forks hit TTD with about like 50-ish seconds apart. And the third fork was extremely behind. So the first 2 forks resolved themselves within a matter of a slot or 2, I think. And the third fork was exactly like Danny said, the amount of time the nodes took to sync up.
Right. Got it. That's really helpful.
Nice. And so, I mean, assuming you have mainnet level participation on some fork, like and you see finality of a proof of work block, then, you know, so on the order of 2 epochs is not only when I'd expect forks to resolve, but also when, you know, things have gone really well or things are chaotic. And yeah.
Cool. That's really useful.
When we had the beacon chain launch, we wrote down what we expected to see and what we thought what some of the bad things that could be over like the course of the first many epochs, and probably doing that so that when we're watching and when others are watching, we can very easily digest what's going on.
Right. Great. So I guess we have the first DevNet up. We've also basically merged both PRs for Kiln V2. I'm curious, implementation wise, how are clients tracking for the V2 spec?
I think I saw Teku Geth
Yeah.
doing the authentication, so at least we have an implementation, right?
Right.
We implemented Exchange transition and we are progressing with authentication, but it is not fully ready yet.
Got it.
Yeah, on basically, we're still actually a couple PRs away from having Kiln in our main merge branch. And V2 auth stuff, we have PRs and we're working on that, but we're not there yet.
Got it. And Nethermind? Oh, sorry, did someone speak up?
Yeah,
Marek already did. Yeah.
I wanted to tell about Aragon. So we are the same as Bezo. We are kind of have a few PRs still left on Kiln V1, and V2 is in progress. So I think the ETA is about 2 weeks.
Got it. Thanks. That's helpful. And Marek?
Sorry, I just said my update about Nethermind. So we are have Exchange transition and we are progressing with authentication.
Nice. Okay. So I guess it seems like we're probably not going to have V2 across everybody next, or maybe we'll have some of them next week. Do we think we want another DevNet next week running V2? Do we prefer to wait an extra week after that to give clients more time? Or do we, is having another DevNet next week, even though there's not everybody, and then maybe having like the real Kiln in 2 or 3 weeks? Yeah, I'm curious what people's preferences here are.
The authentication PR is written in such a way that you can use the old port if you're not ready, right? I believe so. So in that case, I mean, I would suggest we begin to call it V2, put on the pressure to have these 2 done, and if you're communicating on an authenticated port, you get there soon. But I think given that there's a handful of implementations and that are complete and many of them work in progress, I think calling it V2 at this point is probably a good call. I also personally think even if client teams aren't involved, which they probably should be, doing some weekly builds just to kind of get a feel for it and continue practicing the transition is probably a good call.
Andrew?
Someone should add.
I have a question about the ports. I think there was a discussion on Discord whether there should be a single port for the engine API or 2 ports, or we should have some kind of transitionary period. So I'm not certain. The spec thing says that there should be 2 ports, but then on Discord, kind of it was agreed that there be only 1. Maybe we can do 2 ports during the transition and then disable the authenticated port. What do people think?
I think, someone correct me if I'm wrong here, but I think there's 2 separate discussions. One is there's the unauthenticated port and the authenticated port. Before the merge, the unauthenticated port should be removed in every client. We need to make sure that happens. Separately, there's discussion of whether there should be a separate port for HTTP versus WebSockets. And that one would remain either 1 port or 2 ports through the merge.
Yeah, so on the former, I'd say the fact that there are 2 ports allows us to continue to do interop testing for the next month, even if people don't have authentication, but that the non-authenticated port for the engine API, I would say should be deprecated prior to the mainnet releases.
I'd say must, not should.
I can go with must as well. Martin?
Yeah. So I think the whether to have 1 or 2 ports for HTTP versus WebSocket, I know for Geth, it was quite a hassle to have it all work on the 1 port. If all clients, all EL clients can handle that, then that's great. I think we should just do that. Some EL clients have problems with that, then I think we should keep them separate.
Am I correct in the understanding that the problem is that back in 2016 or whatever, when Geth was written originally, the libraries didn't support it seamlessly, but they now do. So in Go, it's relatively easy these days.
I can't say exactly what the problems were back then. Felix and Renee fixed it eventually.
We are not targeting like this, removing this port, unauthenticated port for the Kiln spec. So it may be the version 2 may be released with what we have currently in the spec. I think it works. Yeah, I think we get enough of the feedback on that we can just release the V2 version on Monday, Tuesday, and then have a DevNet whenever we think it's reasonable to have with this new version of the next week.
That seems reasonable. Maybe the one thing I would say is if we can add something in the merge readiness checklist about confirming that we've removed the unauthenticated ports before, ideally, like the public testnets or the release. So not Kiln, but like the Gordy and whatnot. That's probably worth, making sure we don't forget.
Yeah, good point. I'll do this.
Yeah, thanks. Was there anything else on the Kiln specs that people wanted to discuss? Aside from the 43.99 random opcode thing, we'll do that next, but just if there's anything else before that.
There will be minor updates to the spec, but they can be done after V2 is released. This is the strict subset of ETH methods. Instead of broad support of the name of entire ETH namespace. Yeah, and some minor removing these exchange transition settings. One of the statements from probably from this from the specification of this method, it's a bit misleading. So it's unsubstantial. So
got it.
It will be done.
And to be clear, the restriction of a subset of ETH methods is going to just be the set that people are using. So that shouldn't break any functionality, right, Mikhail?
Yeah, right, exactly. Great. So, and on the EL side, it just doesn't need to, I think it doesn't need any engineering because it may be just entire ETH namespace, and we just want this to be restricted in the spec, on the spec level, not necessarily on the client's level.
Got it. Anything else on the Kiln specs?
Just a minor correction there. It may require some engineering for clients because ideally we want the chosen API endpoints in the ETH namespace that are going to be migrated over to the engine API. We want to make sure they're well specified. And so because there is not consistency between clients, some clients may have to adjust some things in order to make them actually spec compliant.
But how do we want to specify these methods? Do we have like, I don't know, one place where these methods are specified, and we'll just say that in order to be compliant with the spec, you should implement this method as it's described in this document. Do you have something like that?
So we do have the JSON RPC spec document. It is not complete, and it basically is the lowest common denominator at the moment. Which means like if three different clients return three different things, the spec currently says your result will be one of these three things. Like, this maybe will be null, maybe it will be 0, maybe it will be empty array or whatever. I do recommend we, for the methods that we port over, we make sure we have much tighter specs before we go live for those methods.
Yeah, agreed. I think any methods that surface in there are subject to, we should all put some final set of eyes and see if there's any ambiguities there.
Yeah, okay. So I was just saying that no engineering is required on the assumption that these methods that I used are more or less unified and have the same semantics and parameters across the client implementations.
One other, I guess, JSON RPC comment or question is, I know we had discussed like adding the finalized kind of status to a lot of the blocks related queries. I'm curious if any clients have implemented that, and if not, what's the like milestone by which we, what do we want to gate based on that? Yeah, I guess first, has anyone implemented kind of the finalized JSON RPC endpoint?
We don't have implemented it yet, and I think Geth doesn't have it too. So
yeah.
Is that an additional bool on a block, or is that an additional endpoint where you can ask if a block is finalized?
It's a Boolean flag, so that if you return a block, basically you can like get the last finalized one. And I think this was also ideally you would also want to have the unsafe tag. So this is like what they
right, okay.
Yep. Yeah.
And we're working hard on that safe unsafe algorithm to be specified, and should make a decision on if and how to surface this sooner than later.
Yeah. And I think we definitely don't need this for Kiln, but we probably want it once we fork the public testnets to make sure that infrastructure providers and whatnot are able to rely on these. So that's one of the non-consensus changes. I think that's probably the biggest in a way, even though it's not a huge.
Yeah, additionally, I think we need to make sure we write about and communicate well about confirmations and finality in this new context.
Yeah. Cool. Anything else on Kiln or the specs? If not, Mikhail, do you want to summarize the summary about the random versus difficulty opcode and the changes you're considering?
Yeah, sure. I'll try to be short and clear. Okay, so current proposal is to rename the opcode to difficulty opcode to random, and it has some issues with this naming, with this particular name, because random is a bit abstract in the context, and under the random name we use the exact implementation of this random machinery, which is the RANDAO currently. And of course, this random opcode, this new random opcode after the merge, returns the randomness output that is much less biasable than what's returned by difficulty in the proof of work. But anyway, it's biasable, and this RANDAO machinery, using the RANDAO machinery under the hood of random has some security implications. Using the RANDAO mix from the exactly previous block, from the exactly previous slot, also has some other security implications. And if we want to like secure random in the future, so we will probably need a bit different semantics of this method. We will probably need this instruction to accept slot number, yeah. So here we have the conflict. So we have this random opcode that doesn't accept any parameter, and to have like a more secure random in the future, we will have to have another random opcode that will accept slot number as a parameter. And yeah, that's why the question naming
Real quick,
has been
why do you have to
rising
have
again.
a slot parameter?
That's because you want your application to use exact the RANDAO mix from exact slot to be less to give proposers less influence power in some circumstances. In the case if we use VDF, it's if we use VDF from a certain slot, which is not that far from the current moment, yeah, this is all about future compatibility. So yeah, we just need this slot number for some reasons, and yeah, that's why the thought is to use the different name. And Alex basically made a good suggestion. So let's just use the name the thing exactly what it is. This is the last RANDAO. The RANDAO has, and we can just explain that RANDAO has its own biasability property. Using the last RANDAO or previous RANDAO also adds more security implications and so forth. So that's like that's the approach I think we should take. Just wondering what people think about it on the naming.
One thing to add to that is this discussion is really just about naming. So it's but the idea here is what we name it is most likely what Solidity is going to name the opcode, and that's most likely what documentation and tutorials and what other going to name it. And what we want is we want to make it clear to users that this is not a good source of randomness. You should not be using this to run a lottery on chain or something like that. In the future, we do want to add some things that will enable those features, but previous RANDAO or whatever is not a good solution for that. It is better than difficulty, so it's iteratively better, but it's still bad. And so naming it just random is very likely to result in people thinking, oh, we've got a random number generator that is secure, we can use that. And that is very much not the case.
But the intention here was to, when you can essentially give you the best randomness and harden it over time with other techniques. So is the intention now to, if you had a VDF, to have two opcodes and to have one that is RANDAO and one that is random or VDF random? Or What do you do? Or do you call it
We could rename
bias
it
field
again,
random
right?
now and rename it again? Yeah.
So
Yeah,
if
we
we
could.
if we use like prev random, and one day we have VDFs, we can, and we agree that like that's true randomness, we can either use random or VDF random.
Yeah, we
Is
could
there
either
a-
rename it, or we can introduce a separated code if it will need to be introduced.
I do think that if we do harden this and intend to harden it, we should make it clear that that's if randomness is hardened, that this opcode will harden it so that applications know that if in the future there's better randomness, they get it by default here. Or we need to make it clear that we wouldn't, because both of them have
Yeah.
implications on how you might design
Right,
applications.
Danny, and one of the ways to make it hardened, one of the requirements is it might not be the case, but it might be the case that we will need this extra parameter. So what we'll do in this case, it's not that clear. So we can't have two opcodes called random, one with parameter, one without it.
Is there a 1-minute description of the VDF solution that convinces me that it will actually be securely random?
You have to
Not
believe
biasable.
VDFs, but you
Yes, assume I believe in VDFs.
you pipe in the input of Randau into a VDF. The VDF is then revealed later. The assumption is that an attacker cannot, when they're deciding to reveal or not reveal, have computed the VDF, the output of the VDF.
Yes.
And so you
I understand
pipeline
how,
these and you have them revealed in the future.
yes, I understand how VDF based random works in general. I'm curious how you would get that all into one opcode.
No, and
usually a two-step process.
I was just gonna say, then naively, like there are many different constructions you can do with the VDF. So like the idea that you'd have a VDF output per slot is probably not correct. You'd probably have one per epoch just because of the way, I mean, you may or may not. So as I verbally explore the notion of just hot swapping this, you know, the semantics are likely different because the granularity is maybe not on a slot basis.
I mean, even if it was on a slot basis, it feels like if you're designing an application to utilize that, you need to have two steps. Basically, a VDF gives you a commit reveal where the reveal is guaranteed. But you need to do a two-step process. It's not a one-step, just read the random generator and you're done. Like,
well, I didn't follow that. I mean, the commit reveal is on the beacon chain level. And so the beacon chain would have these Randau, these VDF reveals essentially. And so if you had it on a per slot basis, you could feed them into this random opcode in the same way.
Right, but like at the moment, we don't know the distance that you need to declare, like if you're making a bet or whatever, you need to bet and then wait a certain amount of time that is longer than the fastest someone can compute a VDF, right? And so we don't know what that number is, and so we can't start advising people on using Randau. And so you really can't build an app today that uses Randau that will then seamlessly switch to using the hardened VDF version in the future, because like the design of those apps.
Yeah, no, and as I think about it, the like naive swap has a number of edge cases to think through. I would be fine calling it pre-Randau or something like that. I do think that it is important to continue forward with the inserting of this value into the difficulty parameter, because almost every every application of difficulty is bad randomness, and this is if we put a 0 in there, it likely breaks things.
Yeah, sure. So I just wanted to add that if we even add currently we add this Randau with that accepts the slot as parameter, it may also increase the security for a bit. So it's not only about VDFs.
Right.
So this is like the solution to support legacy applications that utilizes difficulty at the source of randomness. And yes, the initial intentions, thanks Danny for the explanation, was to harden it over the time. Yeah, but it has some it might have some issues, might make some issues with this.
And if we do harden it, we can always rename it. And I know that it's not like trivial to do, but it's also not impossible given that we're literally doing it right now.
Yeah.
Yeah.
Yeah. That's.
Yeah. In the spirit of like ideally moving forward on this, does anyone object, Prev Rando?
And yeah, Danny, this is good. I mean, if people will start thinking about what RANDAO is, they will go to the spec and read about it and read security implications. If they see random, so it's pretty clear that no security implications needs to be read it on. No, like definition of this machinery will need to be learned. So it's just random. That's also good in terms of introducing some term that requires some additional digging into the specs. And also considering that VDFs are not happening soon, the renaming shouldn't be like, shouldn't induce huge complexity.
Okay, we're up to one final nitpick in the chat. Do we use an underscore or not? Historically, it seems that opcodes do not have an underscore. I don't know if it breaks anything, but to be on the safe side, does anyone?
I wouldn't put underscores in it. I have no preference.
Okay, so Prev RANDAO it is without an underscore.
Cool. Yeah. And if someone has strong opinions otherwise, feel free to talk to Mikhail and me in Discord.
And can we like time box that, like, so that we basically, it would be good if like early next week when we have the Kiln V2 spec, we have this merged and like, yeah.
Yeah, I'd say if you have strong opinions, contact someone like within the next 24 hours.
Yeah, I think I would assume almost anyone with a strong opinion and then has touched this at all is probably right here.
Okay, let's go. Yeah, let's definitely make this final when we release the V2 specs for Kiln early next week.
Yeah, sounds great.
Cool. Anything else on this? Okay. Next up, we have Galen from Kurtosis. Their team have been working on doing like simulation testing for the merge. They've been working closely with a lot of the client teams. Do you want to take a couple minutes to walk you through basically what you've been doing so far and like how clients can use what you've built?
Yeah, absolutely. Thanks, Tim. Hey, everyone. We have been working with Pari and a bunch of the folks on the client dev teams. Our product, Kurtosis, it allows you to spin up multi-client testnets locally. So Kurtosis, we have a layer on top of Docker, and that layer encodes all of the logic you need to tie the things together in a configurable way. We actually have Kevin on the line as well. He's been doing a lot of the deep engineering work for this and can like dive into all the details. But the way it kind of works is when you run Kurtosis on your own laptop, you can run a local network that goes from proof of work to proof of stake with the clients that you want to have. And we have some observability tools in there. You can debug when things go wrong with your particular client or connections between your client and other clients. And you can do that all in a fast iteration loop. So you have more chances to see what's going wrong rather than only waiting for the next merge net when that moment happens. And I'll pass it over to Kevin for a little bit more details on that.
Hey, folks. Yeah, so basically, Kurtosis is a tool. Actually, I can just share my screen really quick.
Sure, yeah.
Let me get to this. Okay, you guys seeing this?
Yes.
Cool. So Kurtosis as a tool is a CLI, just a CLI that gets installed via Homebrew or whatever. And the idea behind it is that you have these things called enclaves, which are sort of like isolated environments where you can spin up a bunch of different services and shut them down and manipulate them. And then under the covers, that actually ends up as a Docker subnetwork, where we spin up a bunch of containers inside of the Docker subnetwork. So you can think of it like a little walled garden for whatever you want. So on top of Kurtosis, we have built what we call a Kurtosis module. And this is a Docker image, this guy right here, that runs a contained set of logic, which in this case is spin up an Ethereum network. First a EL network, and then followed by a CL network, and add a whole bunch of tools and do like bits of validation, like making sure that the EL nodes are mining and the CL nodes are producing blocks, and everything is working in gravy. So I actually took the time to pre-run this before this, just because it takes a little while to wait for like mining and everything to go on. But you can run this locally on your machine. And basically what will happen is that Kurtosis will go ahead and do all the machinery necessary to create one of those enclaves right here. So I've created this ETH2 enclave, and then I've fed in a bunch of parameters. So every module can take in parameters. You can kind of think of it like a function. And this will allow you to configure the actual network that's getting started inside of Kurtosis. So specifically, that allows you to configure the local net that is getting created. So once that gets fed in, Kurtosis is going to do a whole bunch of work, and you can see everything that's going on right here. We're basically generating the EL Genesis data right here. We're going ahead and adding the one EL client, which in this case was Geth, which comes from the specification right here. We're waiting for Geth to get going. I actually I set a couple debugging flags here to make this a little bit faster. You'll see where that'll come in just a second. And then we get the CL client, which is going to get connected to the Geth instance. And then we get some debugging tools on top of this to make sure that our network is working. So the first of which is Forkmon. So there's a Forkmon instance which is started and connected to the network. So we can see that our one Teku node is right here. We can see how slots are progressing. We can see which hashes based.
We're still seeing your command line.
Ooh,
yeah.
Thank you. Let me go ahead and change that. How about now?
Yes,
Yep.
that's Forkmon.
Yep. Cool. Yeah, so basically the module will return output, just like a function. You'll get back a bunch of output in JSON format. And then, I can just go to this Forkmon URL. And this is Forkmon right here. So technically what this is a Forkmon instance that is running inside of a Kurtosis enclave, which means inside of a Docker network with Kurtosis orchestrating all the necessary different parts. And then it is exposed to your machine on a port. So you can see that I've got this ephemeral port up here at the top. And then that allows you to see how the network is going. And then of course, if you had a bunch of different nodes, then you'd see everything going through. And we also have Grafana. We just added this, so we're shaking out a couple bugs with this. So if I go to Grafana, we're actually going to see no data here, which is one of the bugs we're trying to track down right here. But if you start the network right away, you'll see the beacon head slot creeping up, and then you'll see the peer count for each of the nodes. We think that basically there's a retention thing that we have to fix because it seems to drop data like about a couple minutes after the network starts. But once we fix that bug, then you're going to also have Grafana showing up inside of here. And you can basically do a bunch of manipulations with the Kurtosis network as you work with it. So we have, if we do Kurtosis enclave inspect and then the Ethereum network, you can see a bunch of information about the Ethereum network that's inside of Kurtosis. One thing I forgot to mention is we actually spin up a transaction spammer. Thank you, Marius. That will constantly be sending transactions to the network just to make sure the network's actually doing work. And then you'll see a bunch of these other services here, like the CL client, the EL client, Forkmon, et cetera. And then the local port bindings on your machine, if you wanted to connect to them and make requests to them, as well as manipulate them. You can see like the discovery ports and everything like that going on. And yeah, I think that's most of it. We have a couple debugging tools, like you can shell into a service by grabbing the enclave ID, and then like if we wanted to get into this guy, then we could of course have a shell into the service to start messing around with it, just like with Docker. You can grab logs of services as they continue, And then the last thing is you can also dump the enclave's logs and container inspect output to your file system, which is very useful for debugging. So we've seen, like, as people are debugging and find issues inside of their Kurtosis network, one, you can give the repro by just saying, hey, my commands, my parameters that I started the module with are these, which will allow, say, like if a client dev was having a problem, they could give to another client dev. They could be like, hey, you know, these are the parameters I started Kurtosis with. This is how you repro the problem. And then these are the logs and the container inspect output of everything that is going on inside of the Kurtosis enclave. So yeah, it's kind of like a super lightning speed overview of Kurtosis and the Kurtosis module that we built. Any questions, any thoughts?
Can we have like some predefined scenarios, like, I don't know, two miners are mining separate two different forks, and, you know, to just test this transition stuff, like a simple example of it?
You mean like
a scenario would look
miners
like?
are? Oh yeah. So basically, so Kurtosis actually has an API. So the Kurtosis engine is just doing whatever you tell it to. So like start the service, stop the service, repartition the network, dump these logs, etc. And modules are just packages of instructions to the Kurtosis API. So you could actually wrap the module in basically whatever you want. So maybe an easy example of this is like showing how we use our internal tests at Kurtosis. So I use this CLI, right? This module CLI here, like this module exec command, in order to start this module with certain parameters, right? You know, I just pump this JSON file in. But if you wanted to test a very specific scenario, you could even just write like a Go test here, and then hook up to the Kurtosis engine and say, hey, like create me an enclave. And then in this particular case, you'd say execute the module to do whatever scenario you want, actually. And then that would be your predefined scenario. You could even run it as a unit test. You can put it inside a CI. Does that kind of answer the question, or am I missing?
Yeah. Cool.
Sorry if I missed this at the beginning. Does this support all 8 clients? Nethermind, Geth, Besu, Teku, Prism, etc.
So we do have 8 clients. I just want to make sure that they're the ones that you're thinking of. So we have Nethermind, we have Geth, we have Besu, we have Lodestar, Nimbus, Lighthouse, Teku, and Prism. Are those ones you're thinking of?
I was thinking of Aragon in that list as well, but that answered my question.
No, yeah, we don't have Aragon right now.
Yeah. Yeah, I guess, would it be useful for client teams to book like a sort of breakout room to go into this in more detail and cover potentially like some more complex scenarios? I had like 1+1 in the chat, but I'm curious, like beyond Besu, would other teams be interested in this?
Yeah, I'm feeling at least a couple of the consensus there would want to as well.
Okay.
Yeah, one last question. Is it like an alternative to Hive or something complementary?
Yeah, I would say we're definitely complementary to Hive. So the Kurtosis focuses a lot on spinning up the network, like the full network, via Docker containers, rather than doing these specific, like the mocks, and making sure that you're like really getting kind of the low level. You can do that with Kurtosis, but it's like you'd have to handcraft. Doesn't have the tool set that Hive does to like do the. I think Hive is like a network jitter test, if I'm not mistaken. So Kurtosis is more about like, hey, you have the full network, and what do you want to do with the full network?
Oh yeah, it looks like I get it. So Kurtosis is like a system testing, versus Hive is integration testing or this kind of separation. Yeah, I see. Cool, thank you.
Yeah, and to the breakout session, we're totally happy to give folks onboarding. We can do that. I mean, even if folks want to do that after this meeting, we can do it schedule a date in the future as well if that works better. I'm totally happy to give a rundown and dive a little bit deeper in all the different things that you can do with Kurtosis.
Yeah, I mean, if usually we get people to show up if we schedule it. I'm actually away next week, but I don't know if maybe like 1 week from now, like basically Friday at the same time as this call, would make sense. If I don't know if Danny or someone else can just host it, but we know that like client teams can generally attend this time slot.
Sure. Yeah,
Yep,
totally happy.
That works for our side.
Yeah, sounds good. We can get
Okay.
something scheduled.
Cool.
Yeah,
Sorry, go ahead.
I was just gonna say it'd be great to meet all y'all as well, because you probably see me on your Discord. I'm new Breeze on Discord, and I've probably been asking all y'all different questions about how your client works as we've been setting it up in Kurtosis. So great to meet you in person.
Yeah. Cool. I'll create a GitHub event, a GitHub issue with just the information for the session. And I'll try to post a note also in the consensus layer call agenda so that people, that's the day before, so at least we can tell the CL teams that if they want to join, it's basically the day after their bi-weekly call.
Perfect. Sounds good.
Sweet. Any other thoughts, questions on Kurtosis? Okay. Yeah, thanks a lot, guys, for coming on, and obviously for doing all this work to help with testing the merge. Next, so Shanghai stuff. Alex and Danny have put together an EIP to expose the beacon state root in the EVM and have, I guess, pre-EIP or idea about how to use that to enable beacon chain withdrawals. Do either of you want to take a few minutes to walk through kind of the current EIP and how that kind of sets the stage for withdrawals?
Yeah, I can do that.
Cool.
So yeah, at a high level, this is for beacon chain withdrawals, and there's at least two high level pieces. The first one is exposing the beacon state root. We can kind of walk through this EIP. I might even just share my screen in a second and just kind of go through the EIP step by step. And the second bit is just exposing, well, using the state root then to consume withdrawals in some way, and we could share our thoughts on what we're thinking there after. So yeah, let me share my screen and we'll just walk through the EIP.
Sounds good.
Okay, can everyone see it?
Yep.
So 4788, this EIP basically takes like the sort of simplest approach to this. Several of you have already given really good feedback, and I think that we're going to probably deviate a bit from the approach here, but we could just walk through it briefly, and even still there'll be questions and things I'm sure someone will want to weigh in on. So to get started, there's some constants that aren't super important. We'll come to them as we go through this. There's two sort of components to this EIP. The first one is supplying the beacon state root in each execution block and committing to that in some way. Then there's the second bit, which is changing the EVM. So we'll start with the first bit, which is putting it in the block. This EIP suggests to essentially put it into the OMERS part of the block that essentially is enforced with the merge fork to be empty, and we're just not going to use it. You also then commit to this via the OMERS hash like we do today, and then that is how you get into the block. From there, essentially with every block that you have, you then have to say, okay, I'm going to write this to a special storage address that we define. This EIP has this keyed by block number, and if we just skip ahead a little bit, there's comments by Vitalik and others to basically say, okay, we should key this by slot number. At this point, I'm pretty set on this being the better path, and I'm currently working on updating the EIP to index it that way. there is some more complication this way, because if there are skip slots in the beacon chain, you may then have sort of an unbounded amount of work to do to write all the state roots that have been missing from the last execution block to this one. But yeah, I think there's ways around that. And ultimately, we don't expect too many skip slots on mainnet, so it should be okay. Let's see. I think the first thing I can ask is, does anyone have any comments about committing to it in the block? So via the OMERS hash, there's a comment either on the PR or on ETH Magicians about using the OMERS hash in this way. Does anyone want to discuss that right now? Well, I do want to say that if you do fill in for missing slots, I think Beacon block root all of a sudden makes much more sense than Beacon state root. Yeah, so right. Yeah, exactly. Yeah, so there's also that point too. So yeah, this is also why I wanted to discuss this, is there's like a bunch of little decisions. So instead of the state root, we would also use the block root. There's some overhead there because, in my opinion, you mainly want to get to the state. And so then to get from the block root to the state root, it adds a couple of hashes, but not the end of the world.
So I can just lay out my argument for why I kind of weakly disagree with the way the OMERS hash is being used. It's being used that way. It's basically always a list of one, if I understand correctly. And the reason for that is, according to the AIP's rationale, is that it's the smallest change because we don't have to change the layout of the block. I'm curious for execution layer client devs, is it actually significantly easier to not turn that into just a hash rather than an array of one, like an RLP array of a single item? If it's not actually easier in any execution client, then I would prefer to do the right thing, which is just include a hash there, not an array of one item.
There is one other bit there, which is just if there's other things we'd want to change in the block moving forward, then like having this flexibility with this list of OMERS lets us do that. Rather than having just like, you know, the OMERS hash becomes the block root or state root, and then that's that.
Yeah, I feel, is it significantly easier to add items to this list versus just adding items to the block itself? Like, is there a meaningful difference there? Like, I feel like in both cases, you're changing the shape of the block, right?
Are you changing the shape of the block? I mean, a list is a list.
Yes, but I believe the list is in the header. Right, so I mean, one could, like, I mean, this is a bit of a pedantic argument. One could argue that the block is just a list of values, like in a fixed order. And, you know, whether we put an item, you know, in the middle or at the end doesn't really matter. And again, this is, I'm curious from execution layer client devs perspective, is this actually easier, or would it be just as easy to have single item?
So what do you mean putting a value in the middle is the same as the end? So there's no, RLP doesn't contain field names, and it doesn't contain schema, so you cannot just put anything in the middle.
Right, so I guess the question is, in the future, so let's say we use the OMERS like proposed here, so it's going to be an RLP list of items, and at the moment that we'll have one item, and then later we've got something we want to add to the execution block header. Is it easier to add it to that RLP list of things that we currently call OMERS, or is it just as easy to just put another item on the end of the block? Like, are those equally difficult?
I would say putting it at the end of the block is significantly simpler because you can just extend the block. So you can just interpret that, hey, there's one more item, we know what the type is, etc. In the OMERS, well, currently it's a hash. What happens if you want to put 33 bytes? Well, you cannot because it's typed that every item is 32 bytes. So the type kind of restricts you as to what you can put in there.
Right. I mean,
I guess also
if that is in fact the case, I'd be totally fine with adding a field instead of messing with this OMERS list item.
From the client perspective, it's also the fact that if we add it as an extra item in the header, then the raw data makes it distinguishable what type it is. If we just, without any further context, if we just put it as a hash where there previously were hashes, it will not be distinguishable from the previous type. From other perspectives, though, we've talked about earlier that if, for example, a header is verified on chain, then if there are such cases, then that will break if we modify the structure of a header. And I think that has been like a governing thought previously. I don't know if we should care about that.
My feeling on that is that I suspect eventually we're going to have to break that, pseudo promise that people think was made. I think there is value in delaying how long it is until we break that promise or lack of promise, whatever, or that assumption. But I do think that we're going to eventually have to break it.
This is the assumption that the shape of the header won't change.
Yeah, like so far the shape of the header is, I think, never changed, right?
Where did base B go?
Oh, actually, you're right. We did just break that, didn't we? Okay, yeah, I'm okay with changing the block header shape then.
I was actually operating on that assumption too, and then I realized that the base B changed it, right? 100% confirmed, yes.
And the base was just appended to the end. So that's the thing. As long as you're appending stuff, it's easy. Once you start leaving anything in the middle, it gets super nasty.
Right. So we could live with the empty OMERS fields forever and just append stuff, and it's a bit nasty.
Well, the empty OMERS field is essentially 1 byte, right?
Right. Yeah.
And we could take over the OMERS hash, as that's an option other than append.
Yeah.
But that is an abuse of semantics and might have its own issue.
Yeah.
So the OMERS hash does take 32 bytes, so that would be nice to not have that just be wasted.
Yeah.
It does compress well.
Yes,
the 0 at the
merge. It'll be just 1 byte or 2 bytes, right?
Oh wait, it's not a 0 at the merge, isn't it?
No, it's not 0. It's like the hash of the empty list.
Right.
Oh, well, that's unfortunate.
Yeah, so my vote my vote then is to use the OMERS hash for beacon state root. Like use that position in the block header for OMERS for beacon state root or beacon block root, and just leave the OMERS an empty RLP list. Maybe at some point in the future, if we need a list of things, we can use the OMERS for that.
I agree, barring an engineering reason not to.
If we use OMERS hash, then we should drop OMERS at all.
We should drop OMERS what?
I mean, if we use OMERS hash for beacon state or beacon block root, then we should drop these OMERS lists from the from the execution block body. Or shouldn't
by drop you mean put a 0 rather than the RLP encoded empty list, or by drop do you mean change the block format?
This is what Peter was getting at, is that changing the shape of existing things is much more dangerous than just adding things on the end or replacing things with similarly shaped stuff. So having an RLP empty list is 1 byte, so it's not too bad. And it's someone who's currently like reading through and parsing what they know doesn't get hurt by that. Like they'll just find an empty list, which is already the case in many blocks. Whereas if we change that to like 0 or something, then someone who's parsing it now is expecting an empty list and they're getting 0, which doesn't make sense, and their parser crashes or breaks or whatever. And so I think we should keep OMERS there. Maybe we rename it to unused or whatever. OMERS hash would become the beacon state root or beacon block root in terms of naming, and that's the position that would go in. That's my vote.
Yeah, I think what Micah said sounds good, just after hearing all the feedback. Does anyone disagree with that?
Can I have a weird question?
Yes.
Let me just, I'm curious, I just want to check what that is. Okay, the uncles, OMERS, where are they stored? I mean, they're not part of the header, and there is no notion of a block RLP format. There's no such thing. It's not a consensus format, the block.
You mean where are they stored right now?
No, I mean, I know. So I'm curious where within the context of the CIP. So it says that omers are stored in the block body, but as far as I know, that's not a consensus thing. So you have the block headers, which has a consensus format. You have the omers, which is just headers, a list of headers, and you have the transactions, which is a list of transactions. But there's no. These are completely. Yes, these are three things stored more or less separately, aren't they?
Yeah, you're just saying like the way this is worded doesn't quite align with current state of the world.
Yeah, then that's a mistake.
So when you say you want to replace omers with some other content, omers are kind of this dangling things, so it's not a field somewhere that you just replace or reinterpret.
So we're just putting a hash into the block header somewhere.
Yeah, but that's the
nothing else is going in. What was that?
Yeah, I was just saying that is the omers hash. So this, for example, exactly in the middle of the screen, there's a number one entry. Set the value of omer fields in the block. There's no omers fields because there's no block. There's no notion of block methods.
Oh, I think that means in the block header, because the block header does have an RLP list of header hashes, right? Or omer's header hashes. And then the omer's hash.
Omers are not in the header, or only omer's hash, but not the
Oh,
list.
I see what you're saying. I see what you're saying. Yeah, I follow now. Sorry.
I'm not sure I follow. The omer's list is in the block somewhere, correct?
It's not. Only the omer's hash is in the block.
So how do you verify?
It's transmitted over the network.
But
it's
the
separate
block
from
body. The block body contains two lists: a list of transactions and a list of headers.
Yeah. Okay. So
yeah, but it's not like
you can put anything in that list, correct?
But it's not.
So the block body is not.
Peter, you explain it.
So the block body is not a consensus struct. It's just defined as something on the ETH network, but you could define it in arbitrarily different ways.
Understood.
Only the header
But you could still take over that and utilize it for something else, especially if you're committing to it in the hash, in the header.
But why do you need to have that something on the side?
I'm not claiming you do anymore. The idea was if there's this place that has a commitment in the header and we might want to grow the things that we want to shove in there, this is a place that could be used. But I'm not claiming anymore that that's a good place to be used.
Yeah. If I understand Peter's and Martin's argument here, this is basically just another argument saying we should put it in the omer's hash because it will let us drop the network traffic of omers entirely. Like we just simply don't need to do that traffic, like pass that around at all.
Sure.
And so we can simplify network layer.
But even now you don't do it. So there's no, if there's no omers, then you don't transfer anything.
Got it.
Not even an empty list?
No, we shortcut. If we see that there's an empty list, we don't even query the network about it.
At least,
interesting. Okay.
If you do a full sync, no, actually no, Geth doesn't require. So Geth just checks it, and if the uncle, the omer's hash is the hash of the empty list or the empty whatever, SHA Merkle tree, then we don't request it. So Geth doesn't do any network traffic. The only thing that costs for Geth is 1 byte per block in the database storing the empty omers list. But again, that would be a lot more painful to reinterpret and hack around than to just extend it differently.
Yeah, but so if we wanted to suddenly swap the actual current header list, which we call the omer list, to some other kind of struct, that would be a big pain in the ass in the downloader. Right, Peter?
Yes, that's what I was saying. Reinterpreting stuff with a different type, that's very problematic.
Great.
So you're saying that we should.
So since there's no schema anywhere, any change, so you can change stuff as long as it's kind of keeps the same shape, the same number of bytes. You can reinterpret fields, but once you change the type of the field, everything goes to, I mean, it just blows up. And in general,
So if
yeah, go on.
So if we put the beacon state root in the OMERS hash field of the header, is that going to cause a whole bunch of problems because you're now going to see that that is not the hash of the empty list, and then you're going to try to query for OMERS or something, or is that relatively easy to have a change that happens?
It's tied to hard fork, so I can just say that, okay, this hard fork block about block number X, the OMERS hash is interpreted differently, that's fine.
Okay.
It's just in general, yeah, things, every single library code that people have written might get screwy because, so for example, one really nice example is that in Click, I reinterpreted a couple of the fields. For example, I reinterpreted the minor field to mean some signer voting thing. And I don't know, 5 years passed or how much, and people are still saying that, oh, why is the minor field all 0? How can I get the minor? So it's, even 5 years down the line, it's causing problems. And okay, obviously Click is relatively minor compared to mainnet, Eth2 stuff, but reinterpreting stuff is a big mess. So as long as we can just add, it's definitely better. If we feel, in my opinion, that the OMERS hash is consuming too much random data, which I agree, we could maybe just add a specification change to allow that field to be a 0 length too. And it should interpret the 0 length the same way as if it were just the empty hash. Or the hash of the empty.
I feel like that would cause more problems than.
But what
the
is
other
the
two
point of trying to send the OMERS on the side instead of just putting them in the header? I mean, that's state root. You can
I mean, it sounds like that's the direction we're heading, is
Yeah,
that we're going to put them in the header.
Definitely very convinced that the abuse of the OMERS list does not bias anything except complexity.
Yeah.
So
that's why I was saying.
So
that
Peter,
yes.
Do you believe that the complexity of replacing the OMERS, the future complexity and problems down the road of replacing the OMERS hash with the beacon state root is worth the cost of having those 32 bytes extra sitting there doing nothing?
So that's what I'm saying. That in my opinion, reinterpreting the OMERS hash is a huge pain in the ass. It's definitely not worth it. And if we think that 32 bytes wasted is a problem, then we can just allow the OMERS hash to be empty, because that way fixing the code to consider the empty OMERS hash the same thing as the hash of the empty thing is very simple. So if we want to optimize out those 32 bytes, that can be done much more simply without reinterpreting the OMERS hash. And for the state root, beacon state root, just dump it as the next field. Don't screw around with existing fields. That's
so
fine.
I'm going to push back a little bit there. My experience with decoding a block header is the opposite. That having a thing that's 32 bytes in that spot would be relatively easy change, whereas making it so what was previously a fixed length field is now not a fixed length field adds significant complexity. This is partially because the way I was doing block header decoding, because I only needed 2 values from the header, is I would just skip forward this many bytes into the header and then read the thing that was at that location. And so we're starting to change the length of items in the header.
I
It
think
moves things around a lot.
There's also
so you can't skip by bytes during RLP instead of unless in very specific circumstances. Normally you have to skip by by index. So you go to next item in the list.
Yeah, so for after the fixed length, so if I remember correctly, it's been a while since I've looked through the header, but if I remember correctly, the first like n items are fixed length. Then you have some variable length.
Well, they kind of
so
are.
For those fixed length one.
They kind of are, but they don't have to be, because if the header were to be extremely large, then the initial length of the header would be consumed more bytes. So in practice, you're right. You can pick up the couple of first fields statically and absolute addressing, but it's not like the robust way to do it.
Yeah, so if I remember correctly, what I would do is I would parse the first few bytes to get that length field off, because that is dynamic, and then I would fixed length jump from there some distance in, and then I would read the length of the next one and then skip that many ahead, read the length of the next one, skip that many ahead, and once I got back to some static fields again, I could jump big blocks.
And that's the hacky way to do it, which has worked, but it's not the robustest way to do it.
Yes, but the hacky way to do it is what you do in Solidity, because you have gas.
Yeah, oh, that's true. Yeah.
Okay, so I think we want to jump to the next topic, but just before that, it sounds like what I'm hearing is that we want to append the state root to the header as a new field and leave the omers alone.
I would like to discuss that more, but it can be out of this call. But yes, the two options sounds like are either replace the omers hash with the beacon state root or append the beacon state root to the end. I would like a little more discussion and like to, but I don't want to consume this call.
Great.
Cool. Any other comments on that? I guess I don't know, Danny or Alex.
I can do a quick on this one. The for a while we were thinking that the path to do withdrawals was first of all you have this route to consume proofs against from a withdrawals accumulator, and you would consume withdrawal receipts to get the ETH back on the execution layer. This would involve a precompile in our thoughts, and would involve a stateful precompile, because you need something like a bit field to say you've consumed receipts, so they can't be consumed before. Given that there are not stateful precompiles right now, and given that there is an opportunity to pull some of the development and verification and testing work out of client team development, we're much more interested in pursuing a withdrawal contract. The withdrawal contract being able to call this opcode that we've been discussing about the beacon block root or beacon state root, taking a Merkle branch and taking a withdrawal receipt that you prove and then consume the receipt, and it stores in its storage whether it's been consumed or not. This would be one function, withdrawal, and has one interesting complexity to discuss. Ultimately, it needs to, in the execution layer, be able to send ETH that was previously deposited and issued on the beacon chain. This is a requisite for a precompile version of it as well, but it looks a little bit more funny coming from a contract. There's two options. One, the special contract, the special function can essentially pull from 0 and send ETH that is validated as in these withdrawal receipts. The other would be to, at a hard fork, dump seemingly infinite ETH into this contract. I think that is the most simple version, but then you have some accounting issues because you have this contract that has 10 to the 30th ETH in it. I think that we're going to put something together and we can discuss this a bit more, Micah. I think there is massive gain to put this in a contract. I think it has a nice symmetry with the deposit contract, and it means that it can be totally parallelized with all of the infinite things that we want to do in the coming couple of hard forks, because it is an independent set that can write the contract, it's an independent set that can verify the contract, and it's an independent set that can audit and test it. But anyway, let's talk about it soon.
One small thing here. It does mean that the user will have to submit a transaction to get the reference withdrawal, right?
Sorry, what was the question? I missed that.
User will need to submit a transaction, a regular transaction, to get the funds withdrawn.
Yes, and that is kind of a requisite. You have push versus pull debate here, but because people have smart contracts that are expected to receive ETH, I think it is most best to be able to do that in a normal contract that has a normal transaction that has to consume gas. But let's move on, I would say, and we'll put a firmer proposal together very soon.
Sweet. Yeah, thanks for sharing. And Alex, you wanted to discuss EIP 4803, which limits the transaction gas to 2 to the 63 minus 1.
Yeah. So this is similar to another EIP we had discussed half a year ago, setting a limit to the nonce. And on that, all core devs also kind of agreed to do multiple smaller EIPs for other fields, because initially we had quite large EIP 1985, which tried to set bounds to every single field in the transaction and also to a lot of instructions in the EVM. Instead of that, we pulled out smaller changes. So the nonce limit was 1 from last year. And this one is only concerned about the gas limit field in the transaction. And this proposed limit of 2 to the 63 minus 1 can be applied retroactively because due to how the gas limit field is validated currently, there never has been a possibility to have arbitrary large limits. So this doesn't need an actual hard fork. There's one added benefit. The main benefit is that, of course, this field is now 64 bits. Calculations are much nicer. And in fact, most of the clients already do this implicitly. The reason we proposed 63 as opposed to 64 is to have space for a sign bit, aka this number can be maintained as a sign number, and checking whether something ran out of gas is a simple check against is the limit less than 0. An added benefit next to this is we could actually get rid of the call depth limit. There's an explanation why on the discussion URL. But lastly, there's also a proposal to maybe not do 2 to the 63, but rather 2 to the 31, because in that case, this number could be, the gas limit could be a regular number in JavaScript as well. So I think that's in short.
I believe the 2 to 31 also gives us some benefit with regards to stack depth, doesn't it? Wasn't this something brought up by the Solidity?
Yeah, I need to run the calculations again, but we ran it with 63. I mean, with the 100 gas minimum cost for any call, I think even the 31 has the same effect on the call depth, but I'm not entirely sure.
Okay.
Andrew?
Yeah, I think, well, Aragon and I think Geth already implement EIP 4803. So that would be a codification of a de facto practice.
I guess, yeah, do any client teams have an objection with this? Okay, does it make sense to do like last time, to just move it to like last call and then check in a couple weeks? Oh, it's still a draft, so I guess you need to move it to review before, then move it to last call, but then check in a couple calls what if client teams have implemented it and then move it to final. And we can also add it to this spec. I think, Alex, you actually added the other EIP that we use to cap. Sorry, what was the other one? I'm blanking on the number. anyway, sorry, yeah, I forget, but we did cap something else recently and kind of retroactively applied it from Genesis, and I think you added that to the execution specs, Alex. So I think we should probably add this at the same place and move it to review, and then move it to final when we have teams that have implemented it.
In the specs, actually, it wasn't just a nonce. I mean, in the execution specs repo, but the check against EOA.
Oh, right. Yes.
Yeah, that also is a similar case. Now, I think this 63 bits that is already implemented practically in every client. But I guess, Micah, if you want to fight for the 31 bits, then yeah, you have to take that up.
I was going to ask if anyone is strongly against 31 bits. If not, I can just debate with Alex out of band, and we will just choose whichever one the two of us agree to.
I'm against it because it's already implemented as 33 bits, so why re-implement it?
Currently in Geth and Aragon, it's 64 bits or 63 bit minus 1.
So currently it's the maximum is as in the EAP, it's 2 to the 63 minus 1, both in Geth and Aragon. So I would rather leave it as is.
Cool. We're at time, but I saw that Gordy is back up. I don't know if Thomas, you have any quick comments you wanted to share? Or anyone else about Gordy?
Sorry, I was searching the window. It was minimized. For now, I can say that Barry is back up. I see that Tendermint Node key was the first one signing after the break. So I just need to confirm with Marek and Mateusz whether it was the node that we are resyncing or we just moved the key to somewhere else while the other validators are coming back as well. And we'll just work on postmortem. We have already scheduled a Monday call to check both the alerting and the node behavior.
Cool. Thanks for sharing. Anything else anyone wanted to cover before we go? Cool. Thank you very much, everyone, and see you in 2 weeks.
Thanks, everyone.
Thank you.
Thanks all. Bye-bye.
Bye.
Bye.
See you.
Bye.